Hello guys, welcome back to another ACT New Horizon tutoring video. Again, today we're just going to be going through some math. What Manoj wanted me to do is kind of just like a range of pretty basic statistics, which is kind of nice, won't be too difficult. So yeah, the main things that we're going to go over, depending on how long it takes, but I think we'll be able to get through all of it, is probability, averages, and proportions. So basically I'm just going to go through kind of the notes for each one and then do several example problems afterwards to just kind of show exactly what that's going to look like on the test. I would say the majority of these types of problems are probably going to be in the range of like the first 20 to 30 questions, just because they are a little bit simpler. Doesn't mean they're always necessarily going to be easy, but like the subject matter itself is simpler compared to some other subjects on the ACT, if that makes sense. So yeah, we're going to go ahead and get started. Like I said, we're going to start with probability. So I'm going to write some notes on that, basically just some definitions, some like rough formulas that you don't necessarily have to memorize because they're pretty straightforward and logical. But it's just important to like get down to the basics and understand exactly what the concept behind probability is so that you can apply it to a range of different problems depending on how difficult they may be. Okay, so the first thing that I wrote up there is kind of like a rough definition, I guess. But it just says that the probability of an event is basically just the set of particular outcomes that we're looking for. So a simpler, more kind of like layman's term of probability is how likely an event is to happen within a set of like different outcomes, or how likely a specific outcome is within a range of outcomes. And when it says like the probability of an event, it's just one particular thing happening, like I said, in a range of different things that could happen. So let's say, for example, you have like a 6-sided dice and you're rolling the dice. The probability that you're going to get, let's say, a 1 is like that is going to be the event. What is the likelihood that you are going to get a 1? And then we'll talk about actually how to find the probability of that, which you guys may already know. Stuff like that for probability is pretty straightforward, but they do complicate it a little bit more within like word problems and stuff like that. Okay, so like I've mentioned before, probability is a pretty straightforward, simple concept. So this is kind of like a working formula for it, but by no means do you have to like write this out every time, just because it's pretty simple. It'll get pretty ingrained. But basically what this says is the P of E, which is just the probability of an event E, is equal to what they call M over N. Again, you don't have to remember that those are the variables that they assign with it. But M over N basically just stands for the number of outcomes in event E. So that's what you're looking for. Or like the outcome that you're expecting or wanting. Divided by N, which is the total number of possible outcomes, right? So it's basically just part over whole, which is kind of neat because we'll see that crop up again in stuff like proportions, which we kind of have already dealt with percents a little bit. So yeah, kind of taking it back to the example that I gave before about like you have a 6-sided dice, you roll it, what's the probability or what's the likelihood that you would get a 1 from that? The 1, we're just looking for one number here, right? So the number of outcomes in event E is 1 because there's only one possible there's only one like concrete outcome that we're looking for, that we're rolling a 1, divided by the total number of possible outcomes. So since there are 6 options, it would just be 1 over 6. And typically you're going to just keep probabilities as their fraction form. You don't really see it written as like a decimal or a percent. That's just kind of the way that like probabilities work. That's typically how you represent them, just as fractions. Okay, so like I said, pretty straightforward for probability, at least in terms of like defining it and like solving it in basic terms, stuff like that, like finding the probability of a simple event. But like I also mentioned before, they will complicate it a little bit. So we're gonna work through some of those more complex problems where you're not just finding the probability of like, what's the likelihood that you're gonna get a 2 from a 6-sided dice. That's straightforward. They're gonna complicate it more on the actual test. So those are the kind of problems that we're gonna go through now. Okay, so like I said, this is kind of an example problem that you may see on the test. Basically, what the setup is it's just going to be a spinner. So there's 8 different regions. It's kind of like a board game. I don't know. And it just asks us, what is the probability that the spinner will land on either 2, 3, or 4, like one of those 3 regions within the spinner. And I don't know if you can see it. My drawing isn't superb. But they have like a tiny little arrow, and that's basically what you're spinning within that circle. So this one is a little bit more complex than like the rolling a dice and getting a 1, but it's the same general concept. So we're gonna work through that now. And I'm just writing the basic formula just so that you guys kind of remember it. But again, when you're working through the actual problems on the test, you want to try to be as efficient as possible, so you don't necessarily need to do that if you remember it. Okay, so like I mentioned before, this formula just says the probability of an event is equal to the number of events that you want divided by the number of total possible outcomes. So when we were dealing with our 6-sided dice example, there was only one outcome that we wanted, right? We wanted to roll a 1. But in this case, we have 3 possible outcomes that we want, right? Either a 2, a 3, or a 4. So instead of writing a 1 up there for the number of possible outcomes that we want, we're going to write a 3, because obviously there's 3 different outcomes that we could possibly want. Obviously we can't get like all 3, but that doesn't matter. So then we're going to go ahead and divide that by the total number of possible outcomes, which in this case is going to be 8 because there's 8 different regions. So that is just going to be your final answer. 3 divided by 8 is going to be the probability that you either land on a 2, a 3, or a 4 when you spin the little spinner on this problem. Okay, so like I said, that one was pretty straightforward, pretty simple. We're going to work on, I believe there's 2 more problems like with regards to this spinner. So I'm going to keep this spinner up there and then just kind of erase like each individual problem as we go through it. So again, another word problem, just because that's kind of the nature that probability problems are going to be set up in. Again, like I said, still dealing with the spinner, but this time it says that the spinner is spun twice, and it wants us to find the probability that the spinner will land on 8 or the region within 8 both times that it's spun. Okay, so first thing we're going to do is just like find the probability of kind of each individual event, right? So we have our P of E is equal to M over N. In this case, like I said, we're just going to start out finding what is the probability of it just happening once. So like, what's the probability? We have 8 possible outcomes. What's the probability that lands on 8 once? And actually, I'm going to see if red shows up any better on the camera. Okay, yeah, that's so much better. Just because green is not doing it today. Okay, yeah, much better. So you guys probably already figured this out, but there's only one possible outcome that we want, right? We want it to land on 8. We only have one outcome, and just like with the problem last time, we have 8 possible outcomes. So kind of forget like what they're actually asking as of right now, because we're just working through the problem and I'm showing you kind of how this works. If we just wanted to land on the region with 8 once, the probability that that would happen is 1 over 8. Pretty straightforward, pretty simple. But that's not exactly what we're looking for, right? Because we're spinning it 2 separate times, and we want to see what is the likelihood that it would land on 8 both times. So whenever you have 2 separate events with probability that aren't necessarily like related, like one wouldn't cause the other, I guess, or yeah, I guess just like 2 separate events, right? Because by 2 separate events, I mean that I'm spinning it 2 different times. Whenever you have 2 separate events with probability, in order to find the total probability of those 2 events occurring in the way that you want them to, you're going to multiply each individual probability, if that makes sense. So the probability that you land on an 8 once is always going to be 1 out of 8, right? Like anytime you spin it, it's going to be 1 out of 8. It doesn't change. So since we want that to happen twice, we're just going to multiply the individual probabilities, like I said, by each other 2 times. So I'm actually going to go ahead and write that down because that's a pretty important concept with probability. Okay, so again, I just kind of wrote down exactly what I just said. To find the total probability of 2 separate events occurring kind of in tandem, I guess, you're going to multiply the individual probabilities. And again, that's exactly what we did up here. So 1 over 8 times 1 over 8 is just going to get us 1 over 64. And that is going to be, like I said before, just like the total probability in this case. We're kind of assigning like, I wouldn't say obscure, like random, because it makes sense. Like total probability is the actual answer. Individual probabilities is just the event occurring once. So as you can see, 1 over 64 is much less likely than 1 over 8, right? Because if you spin it twice, the likelihood that it lands on 8 once already is kind of low. It's like, what is that? A little bit more than 10%. I think it's like 12.5%. But then the probability of that happening again is already lower. So even just looking at this from a logical standpoint, it makes sense. Okay, so that is example 2 with that spinner problem. Now we have one more example with the spinner problem. I'm going to go ahead and write it down up here. But at first glance, it may seem identical kind of to the one that we just did, but it's actually not. And it actually trips people up a lot. And when I say people, I mean myself included, because I used to make this mistake all the time. Whether it was just from like not reading the question closely enough, or just kind of assuming what the answer to the question was, or like assuming what the question was asking. Sometimes I would just like mix it up and not get it right. So I'm going to go ahead and write that down, and then we'll discuss it. Okay, so for this problem, similar setup to the last time, the spinner is going to be spun twice, but this time it's asking what is the probability that the spinner lands on any same number twice? So the way that I'm kind of going to explain this problem and explain my thought process behind it is I'm just going to go ahead and kind of give you guys the answer and then work backwards and explain why that makes sense. Okay, so the answer to this problem is going to be 1 over 8. Now, that may be kind of confusing at first, just because last time we dealt with, like I said, a very similar occurrence, right? We're spinning the spinner twice, and in that case it was 1 over 64, not 1 over 8. But the main difference in this is that it can land on any same number twice. So the first time that you spin the spinner, it doesn't matter what it lands on, right? It's gonna land on something that's 100% likely that that's gonna happen, obviously. But what we're really looking for is that second event, that it's going to happen and then it's going to land on the same number. That is going to be 1 over 8. So I guess technically, if you really wanted to, you could separate this out into like the individual probabilities and the total probability. Because for the first individual probability, the first time you spin the spinner, it just has to land on a number, which is going to be 100%. It's going to land on a number unless it like breaks, but that's semantics. So that's our first individual probability, right? And then the second individual probability of the spinner landing on like whatever number, let's say it was 2. That's going to be 1 over 8 like we've dealt with before, right? So then as you multiply this out, if you want to get technical with it, that's kind of how you get that answer. But yeah, that's the explanation behind this problem. Again, the wording seems very similar to the one we just did, right? But completely different answer. And I can almost guarantee you, if it was like this exact problem on the test, they would have an answer choice that had 1 over 64, just to see if kids were like really understanding it and really reading this question closely. So as with every question on the ACT, just make sure that you're reading it closely and figuring out exactly what they mean and not like automatically assuming just because you've dealt with like kind of a similar problem before. Okay, I think that is basically all I have for averages. I think I actually might, or sorry, not averages, probabilities. Oh, I have one more. I just kind of wrote it in like a different section, but we're gonna go over that one now. Gets away from the spinner, but it still deals with probability, and it's a little bit more complicated, I guess. There's just like some easy mistakes that you can make with this problem, so we're gonna address it, and I'm gonna show you guys why those mistakes are gonna be wrong. so this one's a little bit longer, so I'm going to give you guys a little bit of time to write this down. But it just says that a candy jar contains 20 candies, 8 orange, 7 green, and 5 red. 2 are picked randomly and eaten, so they're not put back into the candy jar. And it's saying that if both of these candies that are eaten and taken out are orange, what is the probability that the next candy chosen is also going to be orange? So yeah, like I said, just take a second to write this down and then we'll kind of work through it. Okay, so hopefully you guys wrote that down. We're gonna work through it now. And I guess to preface this, I would just say that when I first saw this problem, I kind of automatically assumed that it was more complicated than it really was. And I tried like solving it in a more complicated way, but it's not as complex as like you may think. Depending on like, I don't know, your level of mathematical skill or like how many math classes you've taken. At least I do this sometimes, and I know that my classmates do it. We kind of automatically assume that a problem is really harder than it is, just because we're like, oh, okay, it can't be that simple, like that's too easy. But sometimes it is just that easy, which is really nice. So just being able to like recognize that and choose the most efficient way to work it out without having to do a bunch of unnecessary work that's probably going to get you the wrong answer is another really important skill. Okay, so working through this, like I said before, we have 20 total candies, right? But we took 2 out. The fact that we took 2 out and that we like chose orange both times does not factor into the final probability that we're gonna find, because it's not dealing with like, oh, what's the probability that first we choose 2 orange and then we choose another orange. That's not the case. It's just saying that they did choose 2 orange, like that is a thing that happened. So if we have 20 total candies and we take 2 away, that seems like first grade math, but obviously we're only gonna have 18 total candies now, right? So we have 18 total. Another thing that we have to factor in is the number of oranges that we have now that we took 2 oranges out, right? So we had 8 total orange, obviously take away 2, so now we have 8 orange. And now we're getting back into that formula that I talked about earlier, where it's the probability of an event is equal to kind of like the number of desired outcomes that are possible over the number of total outcomes. So in this case, even though there's really only like one desired outcome compared to the spinner one, where it was the one where like the one that I'm talking about is where you could have either spun like a 2 or a 3 or a 4. Those are 3 different outcomes. In this case, we only have one desired outcome, but there's kind of like 6 different ways that we can go about it, right? Because you're not only drawing, and there's not only one orange, there's 6 possible oranges. So part over whole, the part is going to be 6. There's 6 possible orange ones that we could draw from there, and the total is going to be 18. That's pretty straightforward. And then if you were just to simplify it down, this would be the actual answer, even though these are the same thing. ACT, like 90% of the time, always wants the simplest answer. So yeah, that's what it's going to be. Like I said before, the mistake that I made is I tried to factor and like multiply the individual probabilities. So I took, I think it was like 6 over 20, or no, 8 over 20, 8 possible orange over 20 total candies times 7 over 19 times 6 over 18. It's not that complicated, it doesn't have to be. So if you guys kind of thought that that was like automatically what you had to do in this case, you're not alone, because I did the same thing. But it really is just that straightforward and simple. So yeah, like I said, that's going to be the final probability question that we do. So now we're going to move on to averages, which I'm sure you guys already know like what average is, but again, it's still important to kind of get back to the basics and then show you guys some more complex problems, because most of the time ACT isn't just going to be like, oh, a class took the test, these were like the scores, find the average. They might, but they probably assume that like you know how to do that, so they are going to mix it up a little bit. So there are really two kind of like definitions for averages, or two different types of averages that we're going to talk about. This is the most simple, straightforward one. Another word for average is mean. I'm sure you guys kind of already know that. That's dealing more with like statistics, like mean, median, mode, stuff like that. But it's the same thing, where basically it's just the sum of n values, which n is just the number of values that you actually have, divided by n, which again is the number of values that you have. So that would be like the example that I gave before about like a class takes a test. These are their scores. What is the class average? The sum of n values would just be adding like each individual test score to find the sum or the total of it, and then divided by n would be how many kids actually took the test. Okay, so the second type of average that we're going to talk about is what's called a weighted average, which kind of the running definition for that is just going to be an average of two plus, so like two or more sets of values in which the sets do not have the same size. So that's kind of like it's not a weird definition, but it's just kind of hard to like actually picture what that might look like. So we're going to go through an example right now. I would say on the ACT at least, weighted averages really aren't that bad. You just kind of have to recognize that it is a weighted average problem and address it as such. I know, I think I was in like algebra 2 maybe, or algebra. We would do weighted averages and the problems were like, not ridiculously hard, but just kind of annoying. I don't know if you guys remember this or if you're in it right now. You would have to like make a chart, and it usually had to do with like making some kind of mixture of like liquids. It was like 50% this, 20% this, 30% this, how much of blank is in it. It's not going to be that difficult, so if you're like screaming at the thought of weighted averages, it's not that bad on the ACT. So I'm just going to go through like a sample example, that's weird, of what that would look like actually on the ACT. Okay, so this is kind of a lengthy problem, I guess. But basically it just says that a class is going to be divided into 3 groups based on their class average, and it wants us to find what the total class average is. So as you can see here, 3 different groups. Group A has 10 students in it, and the test average for that group is 65%. Second group, Group B, has 7 students, and the test average for them is 80%. And then third group, Group C, has 5 students and a test average of 90%. Okay, so tying this back into our definition of weighted average, it makes sense, right? because we said that a weighted average is going to be the average of two or more sets of values in which the sets do not have the same size. Obviously, there's not the same number of students in each of these groups, right? There's 10 in group A, 7 in group B, 5 in group C. So we know that this is going to be a weighted average because the number of students in each is not equal to each other. So the weight, if that makes sense, of each of these averages is going to be different, and that's very much going to affect your answer. So what you can't do is just take like a basic straightforward average of these three different scores, right? You can't just take 65 plus 80 plus 90 divided by 3, because that's not the case. There were a lot more students who scored a 65% than there were who scored a 90%. So that's basically just gonna like shift it down. It's gonna make the actual class average less than what you might expect if you just took a simple average of these scores. So yeah, that's basically what we're gonna do. I'm gonna go ahead and show you guys the simplest way to do that. There's a couple ways, but I find that the way that we're not gonna do is a lot more complicated, and it's a lot easier to get it wrong. So I'm just gonna show you guys the easiest way. Okay, so I'm gonna kind of explain what I just wrote down. But basically we just have 65 times 10 as our kind of first little bit in this. And that makes sense, right? Because we have 10 students who got, on average, a 65. So we want to find the total number of points that they scored. So that only makes sense to like multiply them and find how many total points that first group scored. And then it's the same exact concept for the other two groups, right? So I don't know why I switched it. But group C scored a 90%. There were only 5 students who scored a 90% on average. So we want to find, again, the total number of points that that group scored. Same exact thing for group C. And then that big line up there, those 3 different products that we're summing together, that is actually going to get us like the total number of points that everyone in the class scored. And then we're dividing that by 22, which at first, if you're just like looking at this problem, you're like, where the heck did 22 come from? There's no 22 explicitly written up here, but that's just taking like the total number of students, right? Again, we're not dividing it by 3, which is like might be a common mistake. The reason you might divide by 3 is because there's 3 groups, but that's not what we want to find, right? We want to find the average in the class with the 22 students. And if you were to divide it by 3, I'm pretty sure you would come up with a number greater than 100, which like automatically hopefully would recognize that that isn't going to be right. So yeah, once you solve this out, this is going to be the answer, 75.5%. And I would just go ahead, if I were you guys and I was like solving this problem in the actual test, I would just go ahead and write this long string into my calculator. That's just going to be the most efficient way, and then you get that as your final answer. Okay. I believe we have one more question with averages, and then depending on if we have time or not, we might just start talking about proportions. so again, kind of lengthy word problem, but it basically just says that Tom and Jerry took a road trip. Tom drove for 2 hours and covered 100 miles. Jerry drove for 1 hour and covered 60 miles, and it wants to find what their average speed is. Okay, so just like looking at this immediately, I can tell, I don't know if you guys can tell, that they're driving at 2 different speeds. And there are a couple ways to go about this, just like there are for most problems. There was for the other problem as well. What some people like automatically do is find their individual speeds and then try to find the average of that. But a lot of times that doesn't work, just depending on the question itself, like the semantics and details of it. And if it's a weighted average, we know that's not going to work, right? So I'll show you guys what I typically like to do with problems like these, and it is what is just kind of most straightforward and almost guarantees the right answer every time. Okay, so if you guys don't already know this equation, memorize it. Super easy, but so helpful. It's just that distance is equal to rate times time. This is obviously dealing with like speed, stuff like that. So what I'm gonna do here is we have 3 different variables, right? Distance, rate, and time. It tells us our distances, it tells us our times, and it wants to know the average rate or the average speed, same thing. So what I'm gonna do is I'm just gonna plug in those individual distances and times into the same equation instead of using 2 separate equations. Like I said, some people might try to do, but it really doesn't work out. So it tells us that Jerry covered 100 miles, Tom, or other way around, doesn't matter. Basically, they covered 160 miles. So 100 plus 60 for our distance is equal to r, which we don't know. And then they drove for 2 hours and also 1 hour. I'm going to find that as well. So then obviously you could like simplify this down. I'm sure you guys don't have to like manually or do it on your calculator, find what is 100 plus 60. But just for kind of the sake of showing how you plug in each individual one into the same equation, just wrote that out. So then divide by 2 plus 1 or 3, obviously. And their rate, once you solve that out, is going to be an average of 53 1/3 mile per hour. Okay, so again, that might seem kind of like a pretty basic question, but I really did just want to cover that distance is equal to rate times time, because it's like kind of an average problem. It is an average problem, but when I was going through the book, they did it in a lot more complicated way, so I just wanted to kind of clear that up and show what I think is the easiest way for that. Okay, so we are almost at time, so we're going to call it a day. Next time, I believe we're working on trig graphing and then just kind of using our graphing calculator in general. So if we do have time, we'll go over proportions more. But we kind of already covered that with percent. So awesome. Okay, so like I said, we're going to go ahead and call it a day, and I will see you guys next week.